Saxon Mathematics, Lesson 68. Locust definition of a parabola. Locust definition we've talked about before. It's a new way of looking at a familiar shape, and it often involves comparing distances. So let me show you what we're talking about. Here's a graph. Here's a parabola that is positioned at the origin, right? The vertex of the parabola is at the origin. That's where we're going to start. We're going to make it harder later, but for now we're making it simple, all right? There is a point inside of the parabola that's called the focus. Draw with me. And if you go outside the parabola in the same direction and draw a line at that point, that's a line called the Directrix, which is a very cool word. Okay, and the way this works is that the parabola is the accumulation of all the points where the distance from, and my picture doesn't make it look like it, but the distance from the focus is the same as the distance to the directrix, okay? That's what locus definition means. It's the location of things. It's comparing, for this point, it can be located at the focus and the directrix, and those amounts will be the same. So that's kind of the underpinning of this whole thing, is that there's this point called the focus that's inside the parabola, and there's a point outside, or a line rather, outside the parabola called the directrix, and all of these points that make up the parabola have the same relationship to the focus and directrix. That's what it means. Now we can write the equation of this parabola as y equals ax squared. Okay, that's just a basic function of a quadratic function, a basic parabola. This assumes that the vertex is at 0, 0. Okay, which is what we see here. And that's what we're going to work on for now. We're going to make it harder later. What we also can say is that this variable, a, can be calculated as, get my formulas straight, 1 over 4p, where p equals the location of the focus on the y-axis. So another way of saying this is that the focus equals 0p. Okay, so that's how we find that value for p, and that space, that distance from the vertex to the focus multiplied by a fraction drives the coefficient that's in the equation. Okay, so what we see is that we can take this expression and plug it in there, so we can also say that y equals 1/4, oh, I'm sorry, this p should be down here, 1/4 p x squared. I'm sorry, that was bad. Okay, the p goes in the denominator. And p, again, is the location of the focus, right? Now, if we want to find this directrix, that is at the line of y equals negative p, because it's the same distance below as the focus is above. So that's where we can locate the directrix. We're going to practice this in just a minute. Obviously, what we're going to do is we're going to do a couple problems like this, where our vertex is centered, or our parabola is centered at the 0, 0 mark. Then we're going to play with what happens if it's not. What if it's off a little bit? And then we're going to do a story problem that seems like it's going to be really, really hard, but it's actually shockingly easy. Okay, so these are the formulas and the definitions that we're going to be using. The definitions are in the picture. So let me put that in there. Make sure that you get this copied into a safe place. You can pause me now if you like. But honestly, this time I'd really like it if you just kept rolling for now, because I don't want this to fall out of your head before we get a chance to go a little further. Okay, so it's this relationship that gives us that locust definition. Locust definitions are always about distances between things. All right, let's dive in. Look, I'm almost to the back of the book. Another book. All right, find the coordinates of the focus and the equation of the directrix. Okay, so we're supposed to, sorry, I didn't write this down. 68.1. We're supposed to find the focus and the directrix and the equation of the directrix. Oh, okay, that's the same thing. For the parabola, y equals tiny little fraction. Hang on. Three-sevenths. X squared. Okay, so we can see from this, and let's see, I've got all my formulas on another page so I can refer to them. Y equals ax squared, so this tells us that a equals 3/7. Okay, that's kind of helpful. Now, in order to find the focus, we have to find p. But we have a really cool equation right here that says a equals 1 over 4p. P's in the denominator. Don't let me make that mistake again. We know it's 3/7. Okay, this is how we found this out. Now, what we can do is we can calculate a, because we can say 3/7 equals 1 over 4p. Actually, we're calculating p, aren't we? I said that wrong. All right. We extracted this value for a. We know that a equals 1 over 4p. That's one of our basic equations. And so we're using this with this value to solve for p. So I'm going to get 12p equals 7. That's cross multiplying. And then I'm going to get p equals 7 over 12. Okay, so the focus is 0, 7/12. Right? Here's my notes I'm working on. Focus is 0p. The directrix is y equals minus p. So in this case, the directrix equals y equals minus p, which is minus 7 over 12. I think that's all we need to know. So let's draw a quick sketch. John doesn't specifically tell us that, but let's do it. Okay, so this is going to be, let's make this +1, and let's make this -1. Whoops, -1, not -7. All right, so the focus is at 7/12 p. So, well, let's just do this. Let's just make this 7/12, and let's make this -7/12. That'll be easier than trying to draw fractions. So this is where our focus is, and this is where our directrix is. And we're not really worrying about how wide or narrow it is, but we know that our parabola is going to go like this. And we know that from the focus to the line, from the directrix to from the focus to the parabola and the directrix to the parabola, if drawn precisely, will be exactly the same. We can label this point as 0, 7/12. And we can say y equals negative 7/12 if we want. But we already said that up there. So we're actually in good shape. All right, that was problem 1. Not so terrible, right? Let's try the next one. The focus of a parabola has the coordinates of 0 and -5/3. And the vertex is at the origin. Well, that's good because that's what we've been assuming for these problems. Find the equation of the parabola, and sketch it. Parable, those are different things. Okay, so what do we know about these numbers? Okay, we know that our simple version applies because of this. We know that the focus is 0.0 p. Aha! So, P equals -5/3. That means we know that the directrix is at y equals the opposite sign, 5/3. So what I'm starting to gather is that this parabola must open down because the focus is always inside the parabola and the directrix is outside the parabola. So that's starting to make sense. In order to find the equation, we need to calculate A. A is equal to 1/4p. So A equals 1/4 times, and there's our P, -5/3. So now we have some complex fraction drama to sort out. It's 1/-20/3. So we're going to multiply it by -3/20, top and bottom. Getting a little messy here, right? So then this cancels, it becomes +1. And A equals -3/20. Okay, we've got our focus, our directrix, those were given to us. We used that to find P. We used P and this formula to calculate A. Let's see, I didn't write my formula down. Let me write that again. A equals 1/4p. That's what we used right here. So I think we've got everything we need to draw the picture. So let's just plop this in. And let's do this as 5/3. And let's do this as -5/3. Our focus is 0, -5/3. The vertex is here. The directrix is positive. So that tells us that this opens down. And again, this locus definition thing means that from the focus to the parabola to the directrix will always be the same, even though it doesn't look like it in my picture. All right? Whew. Okay. So we just have some little equations and we can just go round and round with all of this information. All right, let's find out now, though, what happens differently if we have a translated parabola. If it's not at the vertex, right? If the parabola is shifted in some way, what do we do about that? Well, let me show you the equation of a translated parabola. All right. This we already know. We adjust y by the amount k, and we adjust x by the amount h. And we still have this a variable in front of it, right? Remember before we had this as our basic equation? Well, we just said, okay, subtract k, and from x subtract h, but then we still have the a and the square. Okay, so this is just updated to take into account this point hk that is off center. All right, knowing, as we already know, that a is also equal to 1 over 4p, we can adjust this and make it y minus k equals, I substituted in the other value for a, and then this stays the same. Ooh, that's fancy, right? In these cases, our vertex is at point hk, right? Those are the adjusting numbers for both of those. And the focus, remember before our focus was just at this distance p, this time our focus is at the point h and k plus p. And let's see, I didn't write this down. Our Directrix is at y equals k minus p. All right, puffy cloud of knowledge about all of this. This is going to allow us to do what we were just doing for centered parabolas. Now we're going to be able to do it for translated parabolas. The main thing we need to know is the shift, right? And then we can just play that out into all of the different formulas. So let's practice that in problem number 3. Oh, and this is the last one. Then we do the word problem that, like I said, seems horrifying, but is actually super cute. A parabola has a vertex of -2, 1. Aha, we see we've got values for h and k there. I'm going to write them down right away. H equals -2, k equals 1. See how I got that? Okay. And a focus of -2, -1. Okay, let's see, what does the focus tell us? The focus tells us that h is -2, we already knew that, and it tells us that k plus p equals -1. We know that k is 1, so 1 plus p equals -1. Here's how I know that k is 1. So I substitute it in here. I subtract 1 from both sides, and I get that p equals -2. Okay, so now I've got that number figured out as well. I can now write the equation of the whole thing. And that will be y minus k equals a, which is 1 over 4 times p minus 2. I'm working on this as my base equation. X minus h, my h is -2, so it's actually going to be +2. Okay. Now, squared. All right. Now let's clean this up. What we usually like to do is we like to take this and tack it on the back end over here so that everything's on this side and it's just y by itself. So we'll do that. Y equals, this is -1 over 8 times quantity x plus 2 squared plus 1, because we're on the opposite side. So there's our equation. What else did John want from us? Write the equation. Oh, the directrix and the axis of symmetry. Sketch the parabola. Okay, the directrix will be y equals k 1 minus p, so that's at y equals 3. And the axis of symmetry is simply, the axis of symmetry is x equals minus 2, which we know from what? We know that the vertex is at minus 2. All right, so that's how we know that. All right, let's see if we can draw this. I don't want to draw it in such a tiny space. I'm going to draw it in my auxiliary book, which I last used for your logarithm piece. All right, I'll put this up here once I get it squared away. All right, now we look first at the focus and the directrix to find out if the parabola goes up or down. The focus is at -2, -1. The directrix is y equals 3. So that tells me it opens down. So let's do this. There's 1 and 2. So here's our axis of symmetry at -2. The directrix is at +3. So let me mark that off. And I'm going to write, okay, here's my axis of symmetry. That I know is the center of the vertex. The directrix is outside of the parabola, and it's half of that distance thing, right? That balancing act. Let's put the vertex in. The vertex is -2, +1. So there's the vertex. All right, and then let's put in the focus. The focus is -2, -1. So that's going to be like right there. And now, this is the focus. This is the vertex. All right, is there anything else we need? I think we've got it. Yep, that looks good. So now what I can do is from the vertex, I want to go down. And we're not worrying here about getting an extra point or anything like that. We're just using the information that we have. And that looks pretty much like the picture. I'll show you the picture. All right, here's our axis of symmetry at x equals 2. Here's our directrix at y equals 3. Vertex, focus. Yay! We did it. All right, now we're going to try this application problem. And it's about a parabolic antenna. It's one of these great big radio dishes that are built in different places of the world to bounce information out into space. There's a great James Bond movie about James Bond climbing around inside a giant parabola like this. I want to say it's in Puerto Rico. But in any case, that's what I always think about. I always think of James Bond climbing around in this dish. Okay. The reflecting surface of a parabolic antenna, that's this whole big thing, has the shape formed when the parabola is, oh look, and there we get the equation of the parabola. So it's three-dimensional, but we don't really have to worry about that. We're just looking at the basic curving shape of it and going, oh, okay, that's a parabola. Is rotated about its axis of symmetry. Okay, well, it's spinning, but what we can see is, look, it's got a vertex of 0, 0. And it may spin, but it spins right there. So that's good. If the measurements are in feet, how far from the vertex should the receiver be placed if it is to be at the focus? Now, you guys, here's the thing. That sounds really long and confusing and hard, but the bottom line is all they're saying is find the point of the focus. Okay, so let's start with that. And look, I'm officially out of paper in my book. Oh, I'll need to get a new one. Wait, what about the back cover? I think, I just hit my light. I think it's a little dark to write on. So I will switch to a piece of auxiliary paper that I will borrow from these Saxon Algebra 2 kids. They won't mind. Okay, so we've got a parabola whose equation is y equals 1 over 20 x squared. We can see, oh, this is example 68.4. Okay, we can see that it obviously is not translated. It must be a parabola at the origin, at the vertex at the origin, because it's simpler. It's not this crazy kind, right, with the adjustments for the h and the k. Okay, good. So we've got a cute little simple one. We know that in order to find the focus, we're going to need to know P, because the focus is the point 0, P. All right? We know that we've got this formula A equals 1 over 4P. So if we've got A, we can solve for P. And look, there's A. So cute. So we can plug this in for A, and we get 1 over 20 equals 1 over 4P. We barely even have to do the algebra. We can guess P is going to be 5, right? But let's just cross multiply. 4P equals 20. And sure enough, we get P equals 5. Now let's stop and see what John is asking. He says, how far from the vertex should the receiver be placed if it is to be at the focus? Well, the focus is at 0, 5, so that means we should place the receiver at 5, it should be 5 feet high. And guess what? That's the right answer. That's not that bad, is it? That's kind of fun. That one was easy. All right, and then the last section of this lesson, I'm just going to show you briefly. It is a little proof, or a derivation, if you will, of how we get to this A equals 1 over 4P. And so what John did is he set up an abstract thing here using the distance between these two and a lot of distance formula calculations, and that's how he shows you how he got that formula. I do not want to slow us down. I feel like this is a meaty lesson already. And what I want you to take away is that when John and I throw, whoops, I just lost the page, so I guess we're not going back. When we throw a crazy equation like this at you, or the other context we had it in, when we throw this craziness at you, we can prove it. We've got the proof, or the derivation, if you will, that can show you that this is true. If you ever wake up screaming in the middle of the night and go, I have to know how they came up with this A equals 1 over 4P business. There it is in the book, and you are more than welcome to look at it. I just don't want to bog us down in a lot of theory, you guys. You aren't all going to be math PhDs, and if you will, you'll have other opportunities to pursue that. But right now, we have our hands full just understanding the basic concepts and working the problems. We do not need to delve deep into the theoretical and philosophical underpinnings of every formula we encounter. Are you with me? Yes, I hear you saying you're with me. So that's the final answer, and that is the end of lesson 68. And now you know all about the Locust definition of parabolas that include the focus and the directrix, the line of the directrix. Okay, that's all. That's enough. Thank you, bye.